At Starbase in South Texas, Starship S38 stands tall on the launch pad, its stainless steel body gleaming in the sun. This is the latest evolution in SpaceX's ambitious Starship program, a rocket designed not just for reaching orbit, but for carrying humanity to the Moon, Mars, and beyond. The sight of S38 reflecting the Texas sunlight is a testament to years of relentless engineering and bold vision. This isn't just another rocket, it's the next leap toward making humanity multiplanetary. With every launch, SpaceX moves closer to a future where space travel is routine, and the boundaries of exploration are pushed further than ever before.
Before every flight, S38 undergoes a static fire, where its engines roar to life in a controlled test. This crucial step ensures that every system is ready for the immense forces of launch, and that the rocket can perform flawlessly when the countdown reaches 0. During this test, the vehicle stays bolted down, held firmly in place as the engines unleash their power, shaking the ground and sending plumes of exhaust into the air. What sets S38 apart is its new, fully integrated thermal protection system, a mosaic of dark hexagonal tiles, nicknamed the Crunch Wrap. These tiles are designed to withstand the searing heat of atmospheric re-entry, protecting the rocket as it plunges back to Earth at incredible speeds. This innovative heat shield is the result of relentless testing and marks SpaceX's confidence in pushing boundaries. Each tile is carefully installed and inspected by dedicated engineers, representing countless hours of research, trial and error. Every component, from the powerful Raptor engines to the advanced tiles, is a product of cutting-edge technology and a drive to solve the toughest challenges in rocketry. The assembly of S38 tells a story of rapid innovation and hard-won progress. Teams work around the clock, refining designs and building on lessons from each previous flight, always striving for greater reliability and performance. S38 is the product of lessons learned from 10 previous flights, carrying the hopes of a future where space is open to all. Each prototype, each launch, has paved the way for this moment, inspiring people around the world to dream bigger. Today, as S38 prepares for Flight 11, we witness a pivotal moment in the Starship journey. A moment that brings us one step closer to a new era of exploration and possibility.
Getting to space is hard, but returning safely is even harder. Re-entry means slamming into the atmosphere at over 25 times the speed of sound, generating heat hot enough to melt steel. That's why a robust heat shield, called a thermal protection system, or TPS, is essential. SpaceX's challenge is to make a heat shield that's not just tough, but reusable, so Starship can fly again within days, not months. Every Starship prototype has tested new tile shapes, materials, and attachment methods, gathering real-world data with each flight. The goal, a heat shield that can survive re-entry, stay intact, and be ready for rapid turnaround. This relentless cycle of building, flying, and learning is what sets SpaceX apart. S38's new shield is the latest and boldest step in solving the reusability puzzle. The Crunchwrap heat shield on S38 is a major leap forward. Its thinner, directly mounted tiles simplify the system, making it lighter and faster to produce. Every kilogram saved means more payload to orbit, whether satellites, lunar cargo, or Mars supplies. The new attachment method aims to withstand launch vibrations and the brutal heat of re-entry, reducing the need for repairs. If these tiles hold up, SpaceX moves closer to true rapid reusability. Instead of perfecting designs in labs, SpaceX tests them in flight. Real-world data, real consequences. S38's flight will reveal if the Crunch Wrap is the breakthrough needed, or if more work lies ahead. Either way, the data will shape the next generation of starships. This is innovation at full throttle. S38's debut is built on years of explosive progress and hard-earned lessons. From Starhopper's first hops to the dramatic belly flop landings of SN8 through SN15, each test pushed the limits. Failures weren't setbacks, they were stepping stones fueling rapid improvements. The move to full-stack launches with the Super Heavy booster brought new challenges. 33 Raptor engines, stage separation, and launch pad upgrades. Recent flights achieved soft splashdowns for both booster and ship, proving reusability is within reach. Each mission refined landing accuracy, tested new systems, and brought Starship closer to operational status. The program's relentless pace has transformed Starship from wild concept to near reality. S38 stands as the next chapter in this remarkable story. Starship's journey is a masterclass in perseverance, innovation, and relentless ambition. From its earliest days at Starbase, the project has faced daunting technical challenges and public skepticism, but each hurdle has only fueled the team's determination to push boundaries. In 2021, SN15's successful landing was a pivotal moment. The dramatic belly flop maneuver, once doubted by many, worked flawlessly, transforming skepticism into genuine belief. This achievement marked a turning point, proving that rapid prototyping and bold engineering could deliver real results. The first integrated flight test in 2023 was another giant leap. Starship cleared the launch tower in a spectacular display, but the test also exposed critical weaknesses in the design. These lessons led to sweeping upgrades, from improved engines to reinforced launch infrastructure, setting the stage for future successes. Flight 4 in 2024 was a breakthrough. Both booster and ship completed their burns, separated cleanly, and splashed down safely. This mission demonstrated that SpaceX could control and recover both stages, a crucial step toward full reusability. For the first time, live video from re-entry and precise landing showcased the system's potential. The world watched as Starship survived the intense heat of re-entry and executed controlled landings, inspiring confidence in the technology. Flight 5 built on this momentum, repeating and improving on previous successes. Each flight demonstrated greater reliability and repeatability, essential qualities for a truly reusable spacecraft. These flights validated Starship's core systems and paved the way for the next big leap, catching the vehicles with the launch tower's arms. This bold step is key to achieving rapid turnaround and true operational reuse. Each milestone, from early prototypes to full-scale launches, has brought SpaceX closer to the dream of operational, fully reusable spaceflight. The pace of progress is accelerating, with each test building on the last. Now, with S38 and the upcoming Flight 11, the focus shifts to perfecting the catch and pushing reusability even further. Engineers are refining heat shield technology and catch mechanisms, aiming for rapid relaunch capability. The next test could redefine what's possible in rocketry, bringing humanity one step closer to a future where space travel is routine, affordable, and truly transformative. All eyes are on Flight 11, the latest and most daring test in SpaceX's Starship program. This mission is packed with ambitious goals that could redefine what's possible in spaceflight. The main event is the trial of the new Crunch-wrapped heat shield, which will be pushed to its absolute limits as Starship re-enters Earth's atmosphere at unprecedented speeds and temperatures. Engineers will be glued to their screens, scrutinizing data from thousands of sensors embedded throughout the vehicle. Their focus: whether the new heat shield tiles can withstand the intense, fiery return and protect the spacecraft as designed. Another historic first for this flight is the attempt to catch the Super Heavy booster using Mechazilla's massive robotic arms, a maneuver never before attempted at this scale, requiring split-second precision and flawless engineering. If this catch is successful, it could eliminate the need for heavy landing legs on future boosters, paving the way for rapid refurbishment and reflight, a key step toward making space travel more routine and affordable. The Starship upper stage will also attempt a complex in-space propellant transfer, a crucial demonstration for future missions to the Moon, Mars, and beyond, where refueling in orbit will be essential. Proving this technology in orbit is a major milestone for deep space exploration, enabling longer and more ambitious journeys. Flight 11 is a high-stakes test, combining multiple technological breakthroughs into a single, daring mission. If all goes well, it would mark a true turning point for Starship's future, opening the door to a new era of space travel. SpaceX is betting big on this mission, and the world is watching, eager to see if history will be made. As Flight 11 approaches, the sense of anticipation is electric. Starship isn't just a bigger rocket, it's a revolution in how we access space. Full reusability could slash launch costs, opening space to scientists, entrepreneurs, and explorers everywhere. Next steps: catching both booster and ship, deploying next-gen Starlink satellites, and proving Starship's commercial power. NASA's Artemis program will rely on Starship to return astronauts to the Moon, using the same heat shield and refueling tech tested now. Each flight lays the groundwork for lunar bases and, ultimately, Mars. Elon Musk's vision of a city on Mars is built on these milestones. Every launch brings that dream closer, turning science fiction into reality. The work at Starbase today is shaping humanity's next great adventure.